Hello and welcome to today's chemistry class for S.S.1. So, our topic today would be balancing chemical equations. But before we continue, I would like to tickle your fancy a bit. You cannot teach a man anything. You can only help him discover it in himself. This is from Galileo Galilei. Now, the lesson objectives. At the end of this lesson, the student should be able to balance chemical equations. So, let's now take a look at how to balance a chemical equation. Using this example, H2SO4 plus NaOH, the arrow, to give us Na2CO3 plus H2O. Now, look at this table. To your left hand, you will see total on the left hand side. And to your right hand, you will see total on the right hand side. The essence of what we are trying to do is to count the number of each atom on every side, that is on the left hand side and then on the right hand side, and ensure that they are the same. Once we see that they are the same, it means the equation is balanced. So now, take a look at hydrogen, which is the first one there. On the left hand side, from the H2SO4, you already have two hydrogen, H2. That means two hydrogens. That's why you see 2. Then there is a plus. Then from the NaOH, that H is one more hydrogen. So on this table, you will see in front of hydrogen 2 plus 1, meaning we have 3 hydrogens on the left hand side. But on the right hand side, we have only 2 hydrogens. That is the one that comes from H2SO4, that H2. Now take a look at sulfur. You will see we have 1 on the left hand side and 1 on the right hand side. Oxygen, we have 4 from H2SO4, 1 from NaOH on the left hand side. If we add the 2 together, we now get 5. 4 plus 1, 5. And then on the right hand side, we have 4 oxygens that come from the Na2SO4 and then 1 oxygen from the H2O. If we add the 4 and the 1, we get 5. And then sodium, Na, we have only 1 on the left hand side and then 2 on the right hand side. That is the one from the Na2SO4. Moving forward, let's take a look at this table. You will note to your extreme right that we have marked it that hydrogen is not balanced because 3 and 2 are not the same thing. Sulfur is balanced because we have 1 on the right hand side and 1 on the left hand side. Oxygen is also balanced, 5, 5. Sodium is not balanced, 1 and 2. So our job now is to find out how to balance this situation. To balance the equation, Let's start with hydrogen. We have 2, the one from the H2SO4, plus 1. You can see I put that one in a bracket. If we multiply that one by 2, plus the other 2 from the H2SO4, we're going to be having 4 hydrogens. Then on the right-hand side, the 2 hydrogens we have, we multiply them by 2 again. It will now become 4. So hydrogen will now be 4 on the left-hand side and then 4 on the right-hand side. Sulfur still remains 1 on both sides. Oxygen will now have a situation. The situation is, don't forget the first 4 we see there is from the H2SO4. Then now we have NaOH. Now that O, that 1 O, that is the 1 in that bracket, times 2. Because we have already, the 2 that is multiplying hydrogen is also multiplying sodium and oxygen in the NaOH. So that oxygen has been multiplied by 2, meaning it will be 2 times 1, 2, plus that 4 from the H2SO4, that will give us 6 oxygens. On the right hand side, the oxygen from the H2O is also being multiplied by the 2 that is multiplying the H2. So oxygen will now become 2 times 1, 2, plus the 4 from the Na2SO4. That will also give us 6. Now let's go to sodium, Na. On the left hand side, 1 times, and I said take note of here, is for a reason. Take note of here. Whatever is going to multiply it will give us 2. Then going to the right hand side, we initially even had 2 in that place. The reason why I said take note is because we need to look for something, whatever, that when we add it up there and multiply, it will balance out sodium but will not distort the other elements that are in the different compounds in the equation. If we now take a good look at this table, you will see that hydrogen is balanced, having 4, 4 on both sides. Sulfur is balanced, having 1, 1 on both sides. Oxygen is balanced, having 6, 6 on both sides. And sodium is balanced, having 2, 2 on both sides. We can now go ahead to input the figures that we use to multiply into the equation. You will see the input now. The figures we are going to input are those ones that are colored. What we just did in the table that passed in the last slide is what is reflecting now on the equation. You can see we now have H2SO4 plus 2 NaOH, that was the 2 that was added, to give us Na2SO4 plus 2 H2O, that's the 2 again that was added to multiply those atoms. So let's now take another example. C2H6 plus O2 to give us CO2 plus H2O. Now, the table to your right, you will see that carbon will have 2 on the left hand side, 1 on the right hand side. Hydrogen 6 on the left hand side, 2 on the right hand side. Oxygen 2 on the left hand side, then 2 plus 1, making it 3 on the right hand side. The 2 plus 1 is that CO2 will give us 2 oxygens plus H2O, that O in the H2O is 1 oxygen. 2 plus 1 making it 3. You can see from the table in yellow that all of them from carbon, hydrogen to oxygen are not balanced because the numbers of the atoms of each of those elements that we have on the left hand side clearly does not balance with what is on the right hand side. Our job now is to do that balancing. So now, let's get started. Look at this table. For carbon, to balance carbon, we go to the right hand side and multiply the one carbon there by 2. 2 times 1 is 2. That will balance carbon. For hydrogen, we have 6 on the left hand side. On the right hand side, where we have H2O, that H2, 2 times 3 will be 6. So we multiply 2 by 3 to get 6. Usually you look for a number that when you multiply with will balance what is on the other side. So we are picking 3, and 3 times 2 is 6. That balances hydrogen. But that will distort oxygen, because oxygen has 2 on the left hand side and now it has 3 on the right hand side. Oxygen is not balanced. So let us go ahead and see how we are going to balance oxygen. Now, the total oxygen that we now have on the right hand side has moved up to 7 based on the 2 that we added. Altogether, we now have 7 hydrogens on the right hand side. Now, on the left hand side, to get 7 hydrogens would be a bit difficult, but it is possible we do it. So let's see how we do it. Now, look at the equation. This is how the equation stands as of now. It is not balanced yet. Oxygen still has an issue. If you check to your right hand side, you will see that the 2 that is multiplying O2 is giving us 4. That's what you are seeing on the table. Plus 3 that is multiplying the 1 oxygen in H2O. That will be 3. So that 4 plus 3, that will give us 7. But on your left hand side, you have only 2 oxygens. Now take a look at this table. Let's go straight to oxygen, because the carbon and hydrogen have already been balanced. If we multiply oxygen, which has only 2 atoms on the left hand side, by 3.5, we will get 7. That's 3.5. We will get 7, which equals the 7 on the right hand side. But you see, that 3.5 might seem strange to somebody who is new to chemistry, but it is normal. 3.5 is normal. But then we can still do something to cancel it out, so that the equation we have now will now look like C2H6 plus 3.5 O2 to give us 2 CO2 plus 3 H2O. So now, moving forward, take a look at this equation. We intend to remove the 3.5, that 3.5, we intend to remove it. So we multiply the whole equation. We're going to multiply the whole equation by 2. So that when we do that multiplication, we will now have something like this. 2C2H6 plus that 3.5 has been multiplied by 2. Now it is 7O2 to give us 4CO2 plus 6H2O. That multiplication has removed that fraction. Let's now take a quick summary of what we have done. In this lesson, we learned how to balance chemical equations. We can now take a quick assessment to see how far you have learned. Copy the following equations and balance each of them. All of them from number 1 to 5 are not balanced. Follow through the procedure and balance the equations. With this, we have come to the end of this class. Thanks for watching and see you in the next lesson.